Hello everyone, welcome to this Women's in Science Day conference, particularly for my talk. So today I will talk about chirality in nature. I am a chemist, so you will see how a chemist looks at this concept of chirality, and the aim of my talk is that I hope I make all of you feel at the end that this is a concept related to everyone here, not just my topic. So let's see. I like to start my talk with this statement: universe is chiral. So please remember this statement till the end of the talk, so you will be able to correlate with this at the end. First, let us understand what is chirality. So let us see an object. You can see a conical flask, which is very common, and see also the mirror image here. Sorry. Mirror image here. If you bring them together, these two images, it's always same. So you don't differentiate between them. So now this is not chiral. This is called achiral. And next example, see your hands, left hand and right hand. They look similar, yes, but keep them one above another. They are not similar. They are not same. So for your eyes, they may look similar, but they are actually mirror images of each other. And exactly this is what chirality is. Chirality means handedness, and that is the meaning of the word, and it's derived from the Greek word. And what is more important is, in nature, molecules also has this property of handedness. If you see here in the image, this is an amino acid, and consider this as left-handed, and there is another possibility which is its mirror image, and that's right-handed. Now these both have they can have different properties, and these are the examples I want to show so that you understand visually how handedness looks like. And probably you have seen these images in your everyday life, encountered it. These are the images of shells, which are from different snails, and they have handedness. You can see the antlers, so you can see the left antler and right antler, and this is the plant tendrils. They also, you can see, coiled in different handedness. So this is what exactly it looks like, handedness. Coming to why this concept is important, there are a lot of research areas which are dedicated, and a lot of research is important because if they can have different properties. If you think about food, which is very common, so see this example, it's called limonene, and these are different mirror forms. They both have different flavor. One gives orange, one gives lemon. And see the next example, it's carbon, and they also have different flavors, different mirror forms. One gives cumin flavor, one gives mint flavor. And I will show you now one most famous example for being unfamous is this drug thalidomide, which is known for birth defects. And the reason is there are two-handed forms. One is useful for treating lot of anxiety, morning sickness in pregnant women, but the another form leads to birth defects. And in your body, in our body, so there are enzymes which can convert this good form to this bad form. Bad in the sense harmful form, toxic form. So this is the reason. So it's very important for us to understand the concept of chirality and do a lot of research in this area. Now coming to how it all came, just when life formed, we don't know that there is something called chirality, and there are always a lot of scientists who do research, but there is always the most important person in every area. And in this area, the most important person, I would say, is Louis Pasteur, also famous for a lot of other discoveries like pasteurization, wine fermentation, all these things. So he's father of molecular chirality, and the reason is he was able to understand and observe something which a very big scientist before him couldn't observe. And what is it? If you see the crystal shapes here, you can see they are actually mirror images. So this is these crystals belong to salt of this tartaric acid, so it can exist two forms. So many scientists before worked with this molecule, they thought it's same, but when Pasteur observed these crystals, he understood that they look same, but they are actually mirrors. So what he observed is this red marked plane, and he understood they have different handedness, and then he correlated. At that time, not even the molecular structure concept is not very much developed, but even then he was able to correlate that this handedness is actually coming from the molecule. This shape is translated from the nature of the molecule itself. And after him, anyway, there are a lot of other discoveries and so many breakthroughs, but he is the first. And then in 1991, so Italian Chemical Society started giving a chirality medal for scientists who do great research in this area. And I would like to quote here Professor Lahav from Weizmann also received this chirality medal. And you can see the picture itself, you can understand it's different mirror images. And next is, I want to show you quickly how you understand chirality in molecule. So when I say about the term chirality, what I want all of you to look is unsymmetry. Suppose see this center ball, it is surrounded by 4 different balls. So it doesn't have symmetry, it have an asymmetry, and this is called chiral center. But it's not the only thing, there are different ways one can have chirality molecule. So, and this have chiral axis. So you can see different balls are not on the same center, but for an axis they are different. And there also the another possibility is chiral plane. So different size of the plane are different, and that can also have handedness. And another example is helical chirality, which means a turn. You can think of a screw having different types of turn, clockwise and anti-clockwise. So these are the 4 types of chirality that exist in molecules. And now that we have seen from molecular perspective what chirality is, now let us go back to the life and understand a bit more. So life has this ability to choose one-handedness preferably over another. And the most famous examples are sugars and amino acids. So the sugars in the nature, they are right-handed. Glucose and the sugar you use in your home, sucrose, they all are right-handed. Whereas the amino acids, which are building blocks of the proteins in our bodies, they are left-handed. And this is very important. But here I like to add a statement that I worked in my PhD with this sugars and carbohydrates. And what I actually studied is how they assemble in solid state and their polymerization. So why this homochirality is important is all the functions in the sense, activities performed in our body are dependent on this. You can see in picture here, consider this as an enzyme having different binding pockets, and this as a molecule with handedness, and assume that when this fits into these pockets, it leads to some activity. But if you see the mirror image, mirror here, mirror molecule, it cannot fit. So you can see in our bodies, so this only one can be active, and also life prefers to have this one activeness. But the missing link here is how and why. How did it all started? We don't know. And why life has chosen one over another. So there are no real answers for these questions. There are theories and speculations saying probably it started random at some point and then amplified over time. Or there is also another theory, subatomic particles itself have some handedness, and probably that have lead to this increase in one-handedness in life. But there is no clear evidence which connect these theories to the real life origin. And the reason is, when Earth started and life started, the climate of Earth is entirely different. And over so many million years, there were earthquakes, volcanoes, changed a lot of climate change. And now for people to imitate the climate of the origin, when life origin is very difficult, which is why it's hard to establish the fact why. But there are definitely a lot of research going on to establish, and one interesting thing is scientists found that the outer space objects whose whose age is more than Earth, far older than Earth, they have chiral molecules. So, but then how did chiral molecules end up in this outer space objects? But we can understand that chirality was there even before life formed. And one more interesting discovery recently happened in 2016 was for the first time in space, which is close to our middle of our galaxy, scientists found a chiral molecule, propylene oxide. So this is the first molecule detected in space. So this clearly gives some directions to find answers in the future, how probably with more search and finding more chiral molecules, this will give some understanding how life has chosen this homochirality. So for now, what I can say is that the quest continues. With this, I like to end my talk, and before ending, I would like to thank the conference committee for arranging such nice event, and also my group members here. I work with Professor Rafael Clan group, and I would like to dedicate and give my special thanks to the most important women in my life, my grandmother and my mother. Thank you.
Thank you very much, Hema, for this really nice talk. Any questions? We have time for two. Yes.
Yes. How do you decide which one is left-handed and which one is right?
So there are very less ways to detect, and one confident way to detect is through optical activity. So optical activity can be tested, and this test is like you take a light, and light has so many directions. Light can pass through different directions, and you filter this light through a polarizer, and now this light have one kind of oscillation. And now if you pass this light, polarized light, through the chiral molecule, so it can rotate this plane either right or left. So if it rotates right, it's right-handed. If it rotates left, it's left-handed. So that is the only way to confirm which is right-handed, which is left-handed. And that is exactly why in the final slide I have shown the molecule found in space. So scientists know it's chiral, but they cannot detect which handedness it is because of the difficulty in characterization through regular spectroscopic techniques.
When we're talking about the handedness of sugars or proteins in the body, so I assume that it can help also to diabetics if they can differentiate between the left and the right handedness of the compounds. Maybe only one of them is causing the damage and the other one is not causing the damage to the body.
Yeah, but there is no reason why it started. Because our body is chiral, it can detect chiral molecules. But why this chiral has come? Okay.
Try to look at it and how can it help the body if you are using another chemic, let's say a mixture of the sugars, but only one of the enantiomers of it. So if you try to look at it, did you try to?
No.
No. Okay.
No, I never tried because I never worked really in this area. So I worked mostly in solid state, how they polymerize.
Okay, let's thank again Hema. Thank you very much.